Okay, 52, they want to solve the quadratics. So A is 2k squared plus k minus 6 equals 0. Let's factor, right? Let's see if we can factor. So I'm going to make my two columns. You could use decomposition, right? Either way it works, right? Negative 6. So 2k squared would be k and 2k. And negative 6 would be 1 and negative 6, negative 1 and 6, 2 and negative 3, negative 2 and 3, and then I have to reverse one of the columns, so I'll reverse the short one. Now we're going outers, inners, and in this case we're looking for a 1, right? The middle term is a 1. So the first one would be negative 6 and 2, that doesn't work. The next one would be 6 minus 2, that's 4, no. And then I have negative 3 and 4. Negative 3 and 4. So this one, let's show what I'm doing. So this one and this one. I take the outers, k times negative 3, and I get negative 3k. And then I take the inners, 2k and k, and I get 4k. And that equals 1k. So that gives me the middle term. So factored, that we would write it right in that order, right? K and 2k, k and 2k, and then 2 and 3, plus 2 and negative 3, minus 3 equals 0. So k plus 2 is 0, or 2k minus 3 is 0. K equals negative 2, 2k equals 3, k equals 3 halves. So I'm going to write the answer up here, right? The answer is negative 2 and 3 halves. There's the answer to A. Okay, let's make space for B. For B, we have, B's quite a bit easier, right? M squared equals 9. We take the square root of both sides. We get plus or minus root 9. So M equals plus or minus 3, right? That one's simple. C, let's make space. C, we have W times 2W plus 8 equals 24. I'll distribute, right? So we have 2W squared plus 8W equals 24. So 2W squared plus 8W minus 24 equals 0. I can factor a GCF out of 2, right? So actually I divide both sides by 2, right? So I get W squared plus 4W minus 12 equals 0. So now the question is, what times what is negative 12, but added gives me 4, right? So what times what is negative 12, and added gives me 4. That would be 6 and negative 2. 6 times negative 2 is negative 12. 6 plus negative 2 is 4. So plus 6 minus 2. So W plus 6 equals 0, or W minus 2 equals 0. W equals negative 6. W equals 2. So the solution, negative 6, 2 for C. And the last one, D, let's make space. D is 3n squared minus 4n minus 5 equals 0, right? I subtract 5 from both sides. So in this case, let's see if we can factor. If I use decomposition to factor, I'd multiply the first and last, right? So I'd get negative 15n squared. So all the factors of that are 1 and negative 15. Again, n, but I'm just saving some time. Negative 1 and 15. And then 3 and negative 5, negative 3 and 5. And added, I need a negative 4. So this is negative 14. This is 14. This is negative 2, and this is 2. So it's not able to be factored, right? So we've gone through our factoring, can't factor. So now my choice is I can complete the square or I could use the quadratic. Let's just use the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. Now, a is, I'm going to write it up here, a is 3, b is negative 4, c is negative 5. So now I substitute in x equals negative 4 plus or minus b squared, negative 4 squared, minus 4 times 3 times negative 5, all over 2 times 3. Okay, now I'm going to come up to here to simplify. So x equals negative 4, that's 4 plus or minus the square root of 16 minus a negative, that's plus 1260 plus 60 all over 6. So I get x equals 4 plus or minus root 76 all over 6. And since root 76 since 76 isn't a perfect square, we leave our answer just like that.